On this episode of Andy's Autosport TV, we're going to pump up your knowledge about fuel pumps. So the reason you'd replace a perfectly good fuel pump is if you're going to go beyond the basic bolt-ons, your factory stock pump will not provide the pressure or the volume that you need to support the serious power upgrades like boost or nitrous. Now, there are several different types of fuel pumps. We're going to talk about the three main ones. You have basically a rotary pump that is designed for high pressure and high volume for your fuel-injected vehicles. And then for carbureted vehicles, we have an electric rotary vane pump and a mechanical fuel pump. Now, the first fuel pump we're going to talk about is a mechanical fuel pump. Now, these are typically on carbureted vehicles, like we said. Now, they run off a cam eccentric, which is basically a round piece of metal that sits on the front of the camshaft, and it's offset. So every time a camshaft spins, this offset metal actually pumps an arm up and down and makes that mechanical fuel pump work. Now, if you're going to do any kind of performance modifications on your vehicle, serious ones like a camshaft or aftermarket cylinder heads, that factory fuel pump is not going to provide the volume or pressure you need. So if you're not going to upgrade to an electric pump, then you definitely need to step up to a performance aftermarket pump. Next, we're going to talk about electric fuel pumps. Now, there are two main styles of electric fuel pump, and it's basically on where they install. Now, we have an inline fuel pump. Now, these were very popular back with the older Audis and Volkswagens and Porsches with mechanical fuel injections. These would install outside on the frame rail. Now, a great thing about an inline pump is if you do have a pump in the tank, this serves as a great auxiliary fuel pump in order to get the extra volume that you need for your high performance upgrades. Now, the next type of electric fuel pump we're going to talk about is an Intank pump. Now, these are primarily for fuel-injected vehicles. However, some manufacturers have started producing electric fuel pumps for carbureted vehicles that mount in the tank as well. Now, there's several advantages to this. One is that if you're going to put an aftermarket fuel system in, you don't have to worry about sumping the bottom of the tank in order to get the pickup down there so you can feed that mechanical fuel pump up front or that inline pump. Another advantage is they don't have to worry about any debris. If you're going to track your vehicle, an externally mounted pump, you're going to be in that debris. If something goes underneath your car, you can possibly take your fuel system out as well. With an in-tank pump, you don't have to worry about that. And the biggest advantage of all is this is actually immersed in the fuel, so the pump actually stays cooler. Now, these come in a variety of different sizes as far as pressure and volume to fit almost all your needs. Now, when it comes to choosing a fuel pump for your vehicle, just because all these fuel pumps are available doesn't mean they'll all necessarily work on your particular vehicle. The best way to go about this is if you have an in-tank pump, stay with an in-tank pump. That's going to be the easiest thing for you. The next thing you need to know is what's the desired amount of horsepower. That's the only way you can figure out the proper fuel pump that you need in order to get the proper amount of pressure and volume. To calculate for the proper fuel pump, use this formula. Now, there's a couple of things that you need to know. The industry standard for a fuel-injected engine is 43.5 pounds of fuel pressure, and for a carbureted engine, it's 7 to 9 pounds of fuel pressure. Now that we know our target horsepower and you have the formula, let's go ahead and talk about our brake-specific fuel consumption. Now, brake-specific fuel consumption is basically the efficiency of the engine. A naturally aspirated engine isn't as efficient as a turbocharged or supercharged engine or a nitrous engine. So we're going to use these multipliers to calculate and make sure we get the right fuel pump for your particular application. So once we figure out that your engine is making 800 horsepower naturally aspirated, you're going to use the brake-specific fuel consumption number of 0.4 to 0.5. If you have a nitrous engine, you're going to use a brake-specific fuel consumption number of 0.5 to 0.6. And if you're boosted in any way, shape, or form, supercharger or turbocharger, that number is going to go to 0.6 to 0.75. This is calculating for the efficiency of the engine. Turbochargers and superchargers are far more efficient than a naturally aspirated engine. So this being said, if you are looking at 800 horsepower naturally aspirated is completely different than 800 horsepower turbocharged. Make sure you use that brake-specific fuel consumption number to get the proper calculation to make sure you get the right fuel pump for your application. All right, we're going to give you two examples of how to do the math. We're going to say that our engine we want to make 600 horsepower, one of them naturally aspirated, one of them supercharged. We're going to start with the supercharged engine, so we want 600 horsepower. We're going to multiply that times 0.75. This is our brake-specific fuel consumption. It's anywhere between 0.6 and 0.75. I'm going to go to 0.75 because I want to be on the safe side. That's going to equal 450 pounds per hour of fuel. Now we need to convert that into actual gallons per hour. So 450 pounds per hour divided by the weight of the gasoline. Now I'm going to do this as super unleaded, and super unleaded weighs about 6.35 pounds per gallon. So we're going to do that, and that's going to equal 70.86 and change. So we're going to need 70 gallons per hour of fuel to support 600 horsepower on a turbocharged engine. Now, if you want to convert that to liters per hour, what you're going to do is you're going to take that number, we're just going to round that up to 71, and we're going to multiply that times 3.79, which will give us our equivalent for liters per hour, which is going to be about 266 liters per hour of fuel. So you're going to need a bigger than a 255 liter per hour pump if you're going to operate a supercharged engine. Now let's go to a naturally aspirated engine with the same kind of horsepower. So we're going to take our 600 horsepower, we're going to multiply that times 0.5, which is the number that we use for our brake-specific fuel consumption again, and that's going to equal 300 pounds per hour of fuel. We're going to take our same 300 pounds per hour, we're going to divide that by 6.35, which is our super unleaded number, and that's going to give us about 47 and a quarter pounds per hour of fuel. Converting that into liters per hour, we're going to take our 47.25, multiply that by 3.79, and that's going to come out to about 179 liters per hour of fuel. So our 255 pump would be perfect for a naturally aspirated engine making 600 horsepower, but not quite enough for a turbocharged version. Now, a lot of the fuel pumps on Andy's website are application specific, but we do have universal fuel pumps as well. So you need to make sure whether you're carbureted or fuel injected when you're looking at universal pumps. And remember that universal pumps are probably going to require some form of fabrication to get them installed. Popular brands we carry are Deechworks, Walbro, Edelbrock, Holley, and Zex. Now, all these manufacturers have application-specific fuel pumps and universals, so check out that product description. For other information about fuel systems, check out our fuel injectors video, and don't forget to subscribe to our YouTube channel. We hope you've learned something today, and we'll see you on another episode of Andy's Autosport TV.